Okay, hey everybody. So this will be the end of the video for the 3D shapes, the last concept we're covering here with this. Okay, so what I have here on the board is a prism, right? And over here I have a cylinder. And we just went through how we find the area, the volume of each one of these three-dimensional shapes. And the easiest way to find the volume of these shapes is you take the area of the base, so in this case a circle, and then you multiply it by the distance between the two bases, so the bottom base and the top base. And for this one, you find the area of the base. In this case, it looks like a rectangle. And then you find the distance between this rectangle and the top rectangle to give you your area, or your volume of your prism. So that works for all prisms. It doesn't matter what the base is. Just find the area of the base and then multiply it by how tall that prism is. Okay, so then what I have then is these. So what if it's not a prism? And what if it's a pyramid or a cone of some kind? So let's take, for example, the cone. Let's take a look at the cone. So you see the cone is basically the same diameter as the cylinder was. Okay, so those are the same diameter. And then this cone, it can fit inside there and it's the same height. You can see it's not quite touching, but also up here, it's not quite all the way inside. So if I could push that all the way inside, it would be the same height. So the cone has the same height as this prism, and it also has the same diameter. All right, put that off the side for a second. Here we got the cube, and we see that this cube's, the base is the same as the rectangular base of this pyramid, and also, like with the prism, the height of that is the same. So we're comparing these two sets because they have the same dimensions. So that's the same as the pyramid, as the prism, and the height is the same as the prism, okay? So the question that I have then is, how many of these would fit inside of here? So if I could break this up and take all the volume in here and put it inside here, what do you think? How many of these fit inside of here? And how many of these fit inside of here? So maybe you think that 4 of these would fit inside of here, but you think only 2 of these would fit inside it. That's fine, it doesn't have to be the same. I'm not saying they're the same, but if you had to guess, what's it look like to you on how many of these pyramids, the volume of this pyramid fits inside of this equal sized prism, and how many of this cone fit inside this equal size of this cylinder? Okay, so go ahead and take a moment, go ahead and press pause and see if you could come up with an estimate how many of these would fit inside of there, and then we'll come back together in just a moment. Okay, welcome back everybody. So if this had been our regular class, today probably would have been your favorite day of the entire year, because we get to go on a little field trip, and you guys would have done this experiment in small groups, and you guys would have gone out and figured out what your answer was and come back, and we would have compared notes with everybody else. Unfortunately, we are not together, so I'm gonna have to do this myself. So what I'm gonna do is I'm gonna go on the field trip. So it's my favorite day, I guess, and I have my my cylinder and my cones in here and my prisms, and we're gonna go on a little field trip all the way from my office to my bathroom. All right, so okay, here we go. So what I'm gonna do, I need to figure out how many of the cones will fit inside of that prism. So what I'm gonna do here, what I did is, you see, I put a little bit of ink in there, dye, so that's green, I think, hopefully. So when I pour, what I'm gonna do is I'm gonna fill this up as best I can with water, and then I'm gonna pour it into the prism, the cylinder, and I'm gonna count how many of these it takes to fill up. Okay, now you might also notice that I had some cutouts there. That makes it easier to manipulate, but I just put tape across there so that I could fill this up to the absolute top. So it's gonna be close. It's not gonna be perfect because this has a little bit of thickness to it, but it's gonna be close to get us a close estimate. Okay, here we go. Maybe I'll do warm water. That might make that dye melt a little faster. Okay, so fill this up best I can. Okay, that's pretty full there. And then I'm going to pour it in. Okay, so there's one. Two, and you can see how full it's getting. Definitely not full quite yet, but let me do one more here. See if that fills it up. And three. So let's see. And sure enough, it took 3 of these to fill that up exactly. So if you guessed that there were 3 cones inside of one cylinder, then you win the big prize, right? So that's what it was. So 3 of these filled up 1 cone. Okay, or 1 cylinder. Okay, let's see what it takes for the rectangular prism that I have here, okay? So now I got a rectangular prism there. And I'm gonna go ahead, did the same thing by the way. You can see I put tape on the edge of that to make it full. And I'm gonna fill this up just like I did for the cone. Okay, so there's that one. Ooh, that water's getting hot, yikes. It's gonna burn me. Here's my second one. I spilt a little bit on that one, so this one might be a little bit off. Okay, so there's 2, and let's see. It's not quite right, so let's go a little bit more and fill that one up as much as I can. Ouch, ouch, and then I pour it in, and we see, barring my stuff that I spilt there, it looks like probably there were 3 of these that filled that up, and that's exactly right. So the connection we want to make between the number of pyramids and the number of cones that fit inside of a prism or a cylinder is that this is 1/3 the size of that, or that is 3 times as big as this. That cylinder is 3 times as big as this cone. So if I know that the dimensions of these two, the cone and the cylinder, are the same dimensions, meaning the same diameter and the same height, and I know that this is 90 cubic feet, then this one will be 30 cubic feet, because this will be 1/3 as big as that. If these two have the same dimensions again, and I know that this one is 15 cubic inches, then I know that one will be 45 cubic inches, because this is 1/3 as big as that, or that is 3 times the size of this. And the same connection there. The dimensions are the same, right? So it's the same size square and it's the same height, okay? If it's the same size square and the same height, then that means that this will always be 1/3 as big as its corresponding prism is, okay? Okay, so that's the experiment. So now we can go do the calculations, and it's quite simple because we already know the equation for volume of a cylinder and the volume of a prism. So if I want to find the volume of a cone, all I'm going to do is take that equation and divide by 3. And I'm going to take that equation and divide by 3 to get to the prism, or the pyramid. So there's a super strong connection between the pyramid and the prism and the cone and the prism, as long as the dimensions are the same size. Okay? All right. So I'll be right back. Okay. So to find the volume of a pyramid or a cone, the only difference between the equation is, instead of having the area of the base times the height, I'm going to have 1/3 the area of the base times the height, or the area of the base times the height divided by 3, whichever makes more sense to you. So so that's fine. So great. So now all I got to do is just find the problem to do. So find the volume of a square pyramid with a length of 10 and the height equals 30. Okay, so length of 10 and the height equals 30. So I'm going to go ahead and just quickly draw what I'm looking at here. So if I have a square pyramid, looks like that. And since it's a square and the length is 10, then the width is also 10. Excuse me. If the length is 10, then the width is 10. And for this height, what we're talking there, actually, I should have said would have been better, would have been the altitude. Okay, the altitude or vertical height. Altitude. That's what we need for volume. Okay, so the altitude, remember, the altitude goes from the peak to the middle of the base at a right angle. So that is what equals 30. Okay, so it's not the slant height. Remember, the slant height is used for surface area. Slant height, surface area. Slant height, surface area. The altitude is used for the volume. Okay, so now I can go ahead and plug that into my equation. And my equation is equal to V equals 1/3 area of the base times the height. For this one, my base is equal to length times width, and then times my height. And the 1/3 in my length and my width are both 10. Whoops, 10. And then my height is 30. Okay, make sure that looks like a 3 there. Okay, so there we go. So we have 10 for the length, 10 for the width, and 30 for the height. So now I'm going to go ahead and multiply this out. And the way that I do it is I say this 3 divides into this 30 10 times. So now I have 10 times 10 times 10, which equals 1,000 cubic units. And that's my answer. Oops, should be cubed units. That's my answer. So I did, or you could go 10 times 10 times 30, then divide by 3. That's fine, but I always simplify first if I can. So you see that it's very similar to the volume of a prism. It's just 1/3 because there's 3 of those cones or pyramids that fit into the cylinder or prism. Okay, I'm going to do one more and then that's it because it's really not that different from the volume of the prisms and cones, but I will do a cone and a cylinder. I will do a cone. So let's see. Cone has a height, an altitude of 12, and the diameter equals 30. This is the diameter. Okay, the diameter equals 30. Find the volume. Okay, so I'm finding the volume. If the altitude is 12 and the diameter is 30. All right, so the equation I'm going to use is V equals, and this time I'll do it like this for those of you that prefer it to be area of the base times height divided by 3. And for this one, my area of my base is a circle, so that's pi r squared. So my new equation is going to be pi r squared times the height divided by 3. And so then I'm going to plug in for what I know, and I know that pi is equal to about 3. My r, if I take half of my diameter, that's 15. So that is 15 squared. And then times the height, which is 12. And then all of that divided by 3. All right, so there we go. So if you get to this point, you've done 90% of the work that I care about, right? And the rest of it's manipulation of the numbers. This shows me that you understand the formula and where these dimensions plug into the formula. So if you happen to screw something up on this multiplication here, I'm not that worried about it. So now what I do know, and the way that I do this, is I know that 3 and that 3 are going to simplify out, just like that. So I'm going to get that the volume is equal to 15 squared, which is about 225, times 12. I might have done that earlier. Can't remember. So now over here, I'm going to do 225 times 12. I'm on the board. Yep. 0, 4, 5, 2, 4. I think it comes out to the volume is equal to 2,700 units cubed. And again, you might want to check my math there because I did that pretty fast. Okay? So that's volume of cylinder or of pyramids and cones, right? It's very similar to volume of cylinders and prisms. The difference is we divide by 3 because the pyramid is 1/3 the height of its corresponding prism, or the cone is 1/3 the volume of the corresponding cylinder. Okay? Okay, so that's it. I'll post a few problems to do, but that's the lesson for volume of 3D shapes.